Hi guys, welcome to the new lecture of chemistry. Now in this chapter, we have discussed these topics till now, and today we are going to discuss about the important graphs and the electronic configuration. Now, in this chapter, we have already discussed about the different models like Bohr model, plum pudding model, Rutherford model, and quantum mechanical model. So which model is correct? It seems that the last one, quantum mechanical model, is correct because it is given in the end of the chapter. So is the Bohr model wrong? Actually, Bohr said we can find the radius of the shell in which the electron is moving, and the formula is R is equal to 0.529 into n square by z angstrom. And he also said that velocity is equal to 2.178 into 10 to the power 6 z by n meter per second. So according to Bohr, we can find the radius also, we can find the velocity also. But Heisenberg said we can't find anything with accuracy. Then came Schrödinger. Schrödinger said this is the Schrödinger wave equation. Find the value of xi. Xi is wave function. Wave function is the amplitude of electron wave, and if you find the value of xi square, that will give you the region where the probability of the finding out of the electron is maximum, and that region is called orbital. So let's see that how xi square varies with the distance when we move far away from the nucleus. Let's start with the graphs, and the first graph is between xi and the distance from the nucleus. Now, this is 1s. 1s belongs to the K shell, and you can see here this black dot is nucleus. Right? So is electron is revolving around it? No. Electron is not revolving around it. These all points are the positions of the electron, and we know that when light falls on electron, it changes its position, and all these points are the positions of electron, and we know that the probability of the finding out of the electron is maximum here. So this is an orbital, this is 1s, and the probability of the finding out of the electron is maximum near the nucleus because the nucleus is having positive charge and it is attracting the electron. And how does it changes? If we move away from the nucleus, then the value of xi decreases. And if the value of xi decreases, so for 1s, we get this type of graph. So this is the value of xi on the y-axis, and this is the distance from the nucleus on the x-axis. And this is the decrease in the value of xi with the distance from the nucleus. Let's talk about 2s. Now this is 2s, this is K shell, you can say. Now between K shell and L shell, there is a gap. We know that energy is quantized, right? So from the nucleus, if we move across at this point, the probability of finding out of the electron is 0. Why? Because this point is between K shell and L shell, and if we go from here to here, the probability will further increase and then decrease, and again at these 2 points the probability will become 0. So you can say that this is K shell, this is K, and this is L shell. 1s belongs to K shell and 2s belongs to L shell. So what we are doing? We are moving from the nucleus, and when we come here in between K shell and L shell, the probability of the finding out of the electron becomes 0, and then again it increases, then decreases, and then 3s will come, right? So if 3s will come, then between 2s and 3s, the probability of the finding out of the electron will be 0. So the graph is like this. Xi is on the y-axis, distance is on the x-axis, and it will come like this. If we start from the nucleus, so Xi is maximum near the nucleus, it will keep on decreasing, and at this point, this particular point, Xi will become 0, because this is the point in between K shell and L shell. Then 2s will come and graph will go like this. What are these plus minus we will discuss later on. Let's discuss about this point. This point is called node. Now what is node? Node is the point or the region or the place where the probability of the finding out of the electron is 0. And we know that there is a gap between K shell and L shell. And I'm talking about this gap. So you can see that K shell, L shell, and in between there is a node. So this is the node, and we have started from the nucleus. If we start from the nucleus, there will be a node, and when we go into the second shell for 2s, then the graph will come like this. And why this graph is moving towards the negative direction, that we have to know, right? Now let me ask you a question. We are plotting the graph between Xi and R. What is Xi? Xi is wave function. And we know that when electron moves, an electron is matter, obviously, there will be a wave associated with it, and that wave is called electron wave. And if the wave is there, there will be an amplitude, that is Xi. And this Xi here at this particular time, it is positive, then it will become negative, then again it will become positive, then it will become negative. This is the property of Xi. So you can't change the property of Xi, you have to take the property of Xi, means whenever there will be a node in between, Xi will change its sign. So there is a node, there is a node, there is a node, and what is node? Where Xi is equal to 0. If Xi is 0, Xi square is 0. And what is Xi square? Xi square is probability density, and where the probability density is 0 means we can't find electron there. So that is called node. So the same node we will find here. Now let us discuss the graph for p orbital. Now this is 2p, and the shape of p is dumbbelled, so the probability near the nucleus will be very, very less, and due to its shape, first it will increase, then it will decrease, and after that here at this point it will become 0. So as we go away from the nucleus, what will happen? The probability will increase, then the probability will decrease. So definitely we will get a dome type of shape. Probability will, or Xi will increase, then Xi will decrease. It's a simple type of a graph for 2p. So these were the graphs between Xi and R. Let's discuss the graph between Xi square and R.